Hello, today we're going to talk about the factor and remainder theorem. Now first let's find the remainder when x plus 2 is divided into this polynomial. So I'm going to put negative 2 in the box. This is an easy polynomial to divide, and we can use synthetic division. So I have 1, negative 2, 2, negative 4, 1, negative 2, and 7. So the remainder here actually should be negative 7. Now if I would take this same function and plug in a negative 2, say if I take negative 2 cubed plus 4 times negative 2 squared plus 5 times negative 2 minus 5, this is what, negative 8, this is going to be 4 times 4, which is 16, that would be minus 10 minus 5. This would give us 8 minus 10 minus 5, so negative 2 minus 5 would give us negative 7. Wow, look, negative 7's there, negative 7's there. What's an easier method? I think this first method might be a quick way to get this value. Let's see if it works here. If I have this divided into this equation, that means I have a 3 in the box, so I'll have 2, 4, 3, 5, 2. And so this would be 2, 6, 10, 30, 33, 99, 104. What's this going to be? 312. So 314 would be the remainder. If I plug in 3 into this equation, 2 times 3 to the 4th plus 4 times 3 cubed plus 3 times 3 squared plus 5 times 3 plus 2. What's that? 81. 81 times 2 is 162. This would be 27 times 4. So 27 times 4, that would give us, that's 8, 108. Here we'd have 9 times 3, which would be 27. This would be 15, and then add 2. So now if we add these together, these two would give us 270 even. And now 270 plus 27 is 297. 297 plus, I guess we could say, combine those to say 17. That would be 314. Did I get the same value? Wonderful, I did. I was a little worried about that, those calculations. But we ended up with the same value. Notice how this is a lot tougher to get to without a calculator than this. So that brings us to the factor, or the remainder theorem. If p of x is a polynomial, then p of c equals the remainder when p of x is divided by the quantity x minus c. So, if I want to find f of 5 in this situation, there's a few things we can do. We could just plug in 5. Like here we plugged in 3. Or we could put 3 in the box and see what comes out. Since 5 to the 4th starts to get pretty tough, and 25 times 33, let's just put 5 in this box and see how this works out. So we have 1, 5, 7, 35, 2, 10, 5, 25, and now this becomes 32. So f of 5 is equal to 32. That's pretty easy. Now, if we divided this, x minus n goes into here, we'd put n up into our box, and we would have a, b, and c. And it would work if I kept going. We'd drop a times n would give me a to the n. Now if I add these together, that would be a to the n plus b. If I multiply that times n, that would be an squared plus bn. And so this would be an squared plus bn plus c would be our remainder, which is the same thing as just plugging n in for x. So that proves that the remainder is going to give us the same thing as an n All right. Now we have another theorem associated with this. That's the factor theorem. That says if x minus c is a factor polynomial p of x, that only happens if and only if p of c is equal to 0. So if and only if, it's by conditional statement saying that if it works both ways. So if it's a factor of p of x, then it's going to have 0 for remainder, and if 0 is a remainder, then it's going to be a factor of p of x. So if we see, is this a factor of this? Let's put a 2 up here. So we'll have 1, 3, -5, and -10. And so this would be 1, 2, 5, 10, 5, 10. Since 0 is the remainder, it will be a factor. Is x minus 4 a factor of this? X plus 4, well, we put a -4 there. Now, we're already up into -44. This is not going to be a factor because this remainder is going to be -54. Obviously not a factor. Now, what are good guesses for zeros in this particular situation? So from here on out, we're going to get an equation, and we're going to ask, how am I going to graph this? So what we need to do is figure out how we can divide this. So here, if I multiplied this out, these three numbers all have to multiply to get to 6. So everything has to be a factor of 6. So we could do plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. Those are all of the factors of 6. Now, what would be good guesses for this one? We know that there's only 2 on this one, that these two have to multiply to get to 12. So our zeros could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now also, we could have a situation where we have 2x plus 1, or 2x plus 3. So what we have to do now is we have to account for that 2 being in there for the first value. So we have to divide each of these things by 2. So there's more possibilities, which are plus and minus 1/2. If I divide 2 by 2, I just get 1. So we don't need to write plus or minus 1 again. Plus or minus 3/2. Plus or minus 4/2 is taken up with 2. 6/2 is 3, and 12/2 is 6. So now these are all of the good guesses for zeros in this particular situation. Now what would be good guesses in this one? There's a lot. 18 has a few factors here. So good guesses for zeros would be plus or minus 1, 2, 3, not 4 or 5, but 6, 7, 8, 9, and then nothing until we get to 18. Now there's a 6 out in front, so we have to divide all of these things by every factor of 6. So we have plus or minus 1/6. So let's first divide these all by 6. Plus or minus 2/6, which is 1/3. Plus or minus 3/6, which is 1/2. Plus or minus 6/6 would be here. Plus or minus 9/6 would be 3/2. Plus or minus 18/6 would be 3. Now, all the factors of this is 1, 2, 3, and 6. So we've already got that taken care of. If we divide each of these by 3, 1/3 is taken care of. 2/3 is not taken care of yet. So plus or minus 2/3. 3/3 is taken care of. 6/3, 9/3, 18/3. All right. So now 3 is taken care of. What about the 2? 1/2, 2/2, 3/2, 6/2. So it looks like everything else is taken care of. So these are all the possible zeros in this situation. Or they're good guesses for zeros. We could plug each of those into synthetic division and see which ones actually work. So now if we're given an equation like this, and we want to find all of the zeros, and we want to actually write this equation out, we would have to guess plus or minus 1, 2, 3, and 6. So what we do is we keep using these with synthetic division until we get at least one integer 0. So I like to start on the bottom and work my way up. You can just randomly plug things in, but it doesn't matter. So if 1 goes down, 1 times 1 is 1, -3, -3, this becomes a 2, 2 times 1 is 2, and so this is -4. So 1 is not a factor. So let's plug in -1. That'd be 1, -1, -5. That gives us 5, which is 10, -10, -16. Since that's not 0, that is not a factor. Now let's do 2. So we would have 1, 2, -2, -4. That would be 1 times 2, which does not get us to 6. So let's try -2 and see if this works. Oops. So 1 times -2 is -2. This becomes -6. That will give us -12, which gets us to -7, -14. That doesn't work. All right. So let's try 3. 1, -4, 5, -6. 2 times 3 is 6. Oh, wonderful. Now we have our value. So now we have this thing, which is x squared minus x plus 2. Now, we know that it has a 0 of 3, so that's x minus 3, which is the factor. Now, let's see if we can factor this. Is there any two things that multiply to 2 and add up to -1? If it multiplies to 2, it would either be 1 and 2, which would add up to 3, or -1 and -2, which would add up to -3. So we can't factor this any further other than using quadratic formula. Now this problem just said find an integer 0, so our integer 0 is 3. Find all the other zeros though. Alright, to find the other zeros, we have x squared minus x equals 2. We'd have to use the quadratic formula. So that would be, remember the quadratic formula? Alright, so if we plug in our values, b would be -1, so negative 1 would be +1, plus or minus -1 squared, which is 1, minus 4 times 1 times 2, all over 2 times 1, which is 2. So that's 1 plus or minus the square root of 1 minus 8, which is -7. So this can be written as 1 plus or minus I root 7 over 2. Or 1/2 plus or minus I root 7 over 2. So these are the other two zeros. So I should go back for a second. We have 1 0 at 3, and the other two right here. So I could write this as a product of linear factors, saying this is x minus 3, because it was at plus 3, and then x minus 1/2 plus I root 7 over 2, and then x minus 1/2 minus I root 7 over 2. Now we have to look up at the original equation. Since the leading coefficient is positive, that's just 1. This leading coefficient will just be plus 1. Alright, now I'll let you guys try this one. Good luck. Alright, now if we do this, the zeros I would try are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Now there's a couple other ones, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and plus or minus 15/2. However, you'd want to try these ones first. 3, I tried this out before, so I'm pretty sure 3 works. So 2, 6, 11, 33, 5, 15. So now 2x squared plus 11x plus 5, and this is x minus 3. Now there's a couple things. Here, the easiest way is to factor it if you know how to factor. If not, then you have to use quadratic formula. If for factoring this, we could take out we'd have to multiply 2 times 5, which is 10. So what multiplies to 10 and adds up to 11? That's 10 and 1. So this would be 2x squared plus 10x plus 1x plus 5. Or we can take out the 2x. And a good mathematician would probably, or should keep that x minus 3 going. And now this one would be x plus 5, 2x plus 1. Now, if we are saying write this in a product of linear factors, we could leave it like that. Or if we want to put it in intercept form, we could take out that 2. And it could look like that. That way you can see all of your zeros, -5, -1/2, and 3. And you can see that, look at its vertical stretch. All right, that should get you through the homework. Good luck.